Hey Fox, welcome back. Today we are diving into something super exciting. If you're working in Web3, AI, or anything that intersects with data ownership and decentralization, then yeah, we're going to work on this in this video. So, hi, my name is Nidhi Akroni. I'm the developer relations at LesAI, and in this video, we are going to talk about data anchoring tokens or DATs, specifically like why does they matter, how do they work, and most importantly, how you can mint one using Python. So let's get into it. So what is dat anchoring token? Let me quickly share my screen and let's get started. Okay. So you can go to the developer documentations and let's go to the introduction part. So a DAT is a semi-fungible token. Think of it like an NFT with powers. So designed to tokenize your AI data and things like models, data sets, or even like computation results. So, but here is the magic. Like unlike the typical ERC20 or ERC721 token, that encourages three core things. So ownership certificate, usage rights, and value shares. So here, ownership certificates is like a proof of contribution or a claim over data sets, models, or a computation results. So proves that you are the contributor of that data. And usage rights, it's access quota. Let me just make it big enough. Yeah, I think that's good. So usage right is like access quota to invoke AI services, example like model calls or agent execution. So usage rights give access to invoke AI services, which is tied to your data. And value shares, it entitles you to economic returns based on the value your data generates. So basically, instead of just tossing your data into the void, you are actually anchoring it to the blockchain and claiming ownership, controlling usage, and earning rewards. The second question would be like, why should we care, right? So AI is hungry for data and contributors really get credit for control. So that flips that model, like whether you are sharing a medical data set, training images, or even like computation results, that lets you prove provenance, track usage, and get paid when your data powers like model or app. So, and it's all done in a privacy preserving way that thanks to encryption layers like OpenPGP. So that's how we do it. And I think let's get started minting a debt uh, using Python. So let's walk through a simple dat minting flow using Python. So first of all, you'll need like three things. Um, Let me quickly share. Yeah, Mint Your Dad. Okay, so you can go to Mint Your Dad tab and you can choose the Python language. So we have like three SDKs available. So we have like in the Node.js, we have in the Rust, and we have in the Python. So you can go to the Python and so yeah, basically you'll need three things: a Web3 wallet like a MetaMask, Python packages, Web3 request, and the Lazy SDK, and your data hosted on IPFS. So first of all, you'll need like the private key from the MetaMask wallet and IPFS JWT token. So how you can get the IPFS JWT token? So you can go to the Pinata and let me just sign in. Yep. So once you're signed in, so let me just delete it all out because I don't need it. Basically, I don't need it. Okay. Deleting files. Okay. So yeah. So how you can get the JWT token? You can create I think that would be creating. Yeah, so you can go to the API key. You can create a new key here and just like mint that in Python, and give like admin access to it and just create it. And here is your JWT token. So I'm just gonna copy it. And when you are done, you just done. So we are using this one. So yeah, so this is like the JWT token. Let me go to the here. Okay. So perfect. So we have the JWT token and we have the private key as well and the funded pre-testnet wallet for the gas. So how are you gonna set up the project? So just create the Lazy AI contribution in Python directory and just go inside that directory. So actually I'm already in that directory. Let me share another screen quickly. So let me share the entire screen, I guess. Yeah. So yep, we are in for the entire screen. Okay. So once you have that, you can go to the cursor. So I have already created a directory and I have already created the directory. We will install it later. Okay. So we're gonna uh, active our virtual environment. So just and then source and active, we are activating our virtual environment. We are in our virtual environment. We're going to install some SDKs and dependencies. So let's just copy it and you're good to go, I guess. Yeah. And then okay, so meanwhile, it's installing. You need to then export private key and IPFS JWT token. So if you prefer like .env file, install python.env and load it at the top of the script. So if you want to use .env, you can like just like uh, load the .env here and use the your environment data. So I'm just gonna export private key just as it is, and my private key starting from 0. And let me quickly um set my private key. So uh yeah, I got it. Sorry guys, just give me 1 second. I'm done. So we're gonna like basically set up the private key, and also we need to set up like export IPFS JWT token. So and like both will goes into the double quoted string, and your IPFS JWT token might be starting with like EY. And let's get to check like if does that work or not. Okay, I'm back. Okay. I hope the screen is visible. Yeah, let's go. Okay, so I have said like peanut IPFS JWT token and this. So then you're gonna just create the simple mint.py file. We already have like dat.py, so which is like simply the same thing. And we're just gonna copy it and let me just check it. Okay, so we're just gonna copy that thing and okay, run Python mint.py. Ah, my bad. Okay, so we're gonna run Python dat.py and it will generate a file ID for us. And we would be able to see it because we deleted like all the things in the peanut IPFS here, where is in the files. So yeah, so on like October 27th, which is like the creation date. So they have created a file named your encrypted data.txt. And this is like the CID for that file. And this is the creation like 11:01:47 a.m. So yeah. So that have created file ID and reward requested for file ID this and proof request sent successfully. So perfectly. So we have like the private data. So let me show you like what we actually stored. Okay. So there might be like data, your encrypted data tags, your privacy data. Privacy data is like your privacy data. So it's just like this data. It can be like here, it can be like anything like your data set, your private data, and you can like pass the your private data, like whatever you have in the data, right? So you can just pass that those datas into this privacy data variable, and it will be stored into here in the what do I say in the peanut IPFS. So it's encryptedly stored because when you like download it, uh,